Hi, I'm Marius. I'm coming to you from Zurich, Switzerland. I want to give a brief overview over two things. What has happened in the TM1py space this year? We've had a release last week, done heaps of implementations this year, lots of new stuff going on, and also what you can look forward to as a user of TM1py in the next few months. So in this presentation, it touches on a lot of things briefly. If there is any topic that you have a particular interest in, I would recommend to join the in-person events next week, in Sydney and Melbourne, where we sort of like deep dive into all the different topics. All right, before we dive in, let's make sure we're all on the same page. I'm not sure everyone knows what TM1py is, so let's just cover this in one slide. So TM1py is the Python package for TM1. It uses the REST API and gives Python access to TM1. And so it allows you to access TM1 through Python and control TM1 and do everything with TM1 that you want to do, but from Python. And that sounds simple, but it has some very large consequences and a lot of potential. And the three main use cases that people use TM1py for is for data integration, especially in cloud environments. When we're talking about data sources beyond ODBC and flat files, very good use case for Python and TM1py. Anything in the realm of AI and predictive, Python is an excellent choice when you have a statistical problem or trying to build a predictive model. So TM1py brings that kind of functionality closer to TM1, which is a good thing if we want to build time series forecasting or all those kind of neat extensions to our TM1 planning models. Last but not least, that was the original reason why I kicked off the project. I just wanted to be able to script Python with TM1. It wasn't really possible. You'd have to do like a data dump into a flat file, and then you could use Python. I wanted to have a more neat integration. Just being able to script things, automate stuff. That's the last point you could ultimately use TM1py for. All right. So what's the state of the open source project now? So we consider TM1py feature complete. If you want to implement any of these use cases we've seen, TM1py should put no constraints on you. You should be good to go and use it as it is now. But that, of course, that doesn't mean it's perfect. And in fact, now this year we've got more contributions than ever, even though we've considered it feature complete at the start of the year. And that's a good thing. That lots of people that we don't even know sometimes, they contribute code and things that cover small features that we haven't covered so far. For instance, just last week, someone introduced a feature to trigger a cube save data on a particular cube. So that maybe I imagine the use case maybe that he's doing a very large data integration script running for maybe an hour, who knows, and then he wants the cube to be persisted directly. So maybe he needs that functionality. So and this is how the project evolves very naturally and grows organically. And so it doesn't stop being developed. Ultimately, what drives the quality, the maturity, and the robustness of open source software is adoption. And I think on that front, we've done quite well. I think from a CubeWise perspective, TM1py is the first thing the first free thing rather, we put out there that has been really widely accepted in the TM1 community. And it's odd if you think about it, right? Because Bedrock for TM1 would have been the more obvious candidate for being like universally adopted in the TM1 community because it's so applicable in every TM1 model. TM1py is still it's not applicable in every TM1 model, right? It's more on the edge cases where you trying to go beyond the out-of-the-box functionality, try to bring in new Python functionality. But still, we've seen very good adoption. We see even other IBM partners using or promoting it, and we're very happy about that, especially when they contribute back, which happens all the time. And TM1py has made it on the IBM radar, even on the roadmap recently. We've just seen this slide recently, where TM1py has been mentioned as a way to integrate. So that of course makes us very happy. Here's another slide from Mike Bender that I was allowed to share that he showed last week on a landscape kind of picture where it shows that IBM apparently sees it as a viable option to use TM1py to do predictive with Python running TM1py locally. So we've seen a lot of adoption recognition recently, and that definitely benefits you as an end user, because ultimately adoption is what drives the feedback loop in open source projects.
On our side, we've started with the EDU classes. So excuse me. So we started in TM1py fundamentals class. That is an EDU class that runs over 4 weeks, 2 hours per week. It has been very well received this year. It has been booked out a couple of months. And that should, if you're interested, definitely reach out to us or to QPy's EDU. And that should show you all the basics, show you where the functionality lays in TM1py, and give you a very good overview. Next year, we're going to do the TM1py intermediate class, starting in February next year, where we look into particular use cases. So we're going to lay it out again over 4 weeks, 2 hours per week. And then in each session, we're going to dive into one use case particular. So maybe we build a predictive model in one session. Next session, we build an end-to-end data integration script. And then we're going to use another session for some kind of automation in TM1. And then, and then today I'm going to speak for the first time about 2 commercial offerings that we're bringing to the market. And so let's first take a look at the new version. So this is version 1.10. I highly recommend to check out the release notes if you're a user of TM1py. If you're not, one of my colleagues, when I showed him the release notes, he called it boring. And that was his response when he first looked at it, because there's nothing really like flashy or that immediately excites you. But at the same time, it may look boring at first, but it's the biggest release in terms of lines of code and in terms of number of contributions we've done in a while. It's also first released since February this year, so it's packed with small enhancements, features, and covers a lot of interesting little things. For instance, we've got some optimizations and improvements built in. Like my colleague Kevin Decker from the Netherlands, he has found ways to improve the speed of the data frame operations that we do. And it sounds a bit boring, but ultimately it gives you better speed on the read and write operations between Python and TM1, and that is key, because typically if you have a TM1py script and you troubleshoot it and you try to see where it could be faster, typically the bottleneck is the I/O, the exchange of data between TM1 and Python. So this is why we've put a lot of effort into making it smarter and faster. All right, we also have a new feature supporting TM1's built-in Git functionality. I know that's a real edge case. If someone's interested in that, please reach out at the end of the presentation. I'm happy to speak about it, but it's still, like, even though TM1py supports the functionality, it's not for the normal. I think for the normal TM1 user, it's maybe a bit too difficult to use it. It's a bit hard to set up, hard to use, but TM1py supports it, and happy to speak about it. I'm just not sure if the majority of the audience is very interested in this Git functionality, but it works. All right, we've got more functionality working with hierarchies and elements, small things here, like very granular small functions to break edges between parents and children, while in the past you'd have to take the full hierarchy, change it, and send it back. That can be very expensive in terms of performance if you have a very large hierarchy. Now we give you more granular function to break specific parent-child relationships, introduce new parent-child relationships, like little atomic operations that give you a bit more control. And we also haven't had an element as ancestor element as parent function in TM1py. But also things have been introduced. And we've got some new search functions to search through your models, search for text in rules or processes. In there again next week during the in-person events, we're going to dive deeper into the release as well. Okay, what is new on the TM1py ecosystem? So this is all the utilities and packages that we put out there over the years. Some of them are already 4 or 5 years old, but they're still being developed and being approved. You see here on the top left, we've got MDXpy. In MDXpy, we also just had a release last week. We've got a new feature that allows you to query cube data and element attributes in conjunction. That's helpful in your day-to-day work, because if you don't have that function, you would have to do 2 queries and then like sort of map it together in Python. And now if you wanted to like query data from products and a couple of attributes from a product, you could do that with MDXpy. That's useful. On the cube calc,
The kubecalc is kind of like a function library of a more sophisticated accounting and mathematical functions. Allows you to easily call them in your cubes, something like internal rate of return or net present value. And it used to have a very drastic performance implication. It used to run on one project at a time. And so if you have 5 projects, it doesn't matter. But if you have 500, it would be really slow. And just now, it's been around for a couple of years, but just now we've implemented it so that you could pass a subset of projects, and then kubecalc goes through your cube. It does it for all your subsets and calculates all the IRRs and puts them back. That's definitely a good enhancement. TM1py, that is a tool that they're all TM1py based, of course, right? They all use TM1py heavily. TM1py is a tool that helps you to find the best dimension order. When we first developed TM1py, we thought of it as a 2-dimensional problem. So we thought you could look at RAM, like what is the memory footprint of the cube? You may want to optimize that, or you may want to optimize query speed, because it's not like a perfect linear line at all. It's not like anything that has low RAM is fast. It's not like that. So you could sort of, what we do is we help you find a good spot, one dimension order that does well on both axes. And now TM1py also considers run speed of processors. So when you call TM1py, now you could say, optimize this cube. Show me some good dimension orders and take into account how long this process runs. And that process, I imagine, could be last year's actuals or something. So you could know it has a low memory footprint. It does reasonably well on this view in terms of query speed, and it does reasonably well at loading actuals. So that's very helpful. Gives you visual results. I'll recommend to check it out. RushTI is probably the oldest utility. Small enhancement there, a couple of weeks old, that if you have individual dependencies between processes, now you could choose that if the predecessor failed, the successor should not run. That is a tiny enhancement, but it has been requested by people, and I can imagine why. TM1py tails. I think that's one of our most recent projects. It's a repository on GitHub where everyone can contribute stories, tales, how they use TM1py, and then we publish them in a blog, and it's being rendered and available for everyone. And we've just had a new contribution recently. Someone posted a story about how to use TM1py with Streamlit to build Python web apps. Okay, on the sample side, there's nothing new. That's because we're gonna publish samples 2.0 soon. So no news from the samples. So TM1py and all of these tools, they will be free and open source, and Kubewise has zero incentive to change that. Now let's take a sneak peek into the Kubewise labs. Yeah, so TM1py is free and it will be. But later this year, we'll go to market with a commercial offering. This is called TM1py support by Kubewise, and the project is a response towards users or organizations requesting 2 things from us. Some people have reached out and requested something like official vendor support. So some people ask for that, I imagine, in order to be able to use TM1py in the first place. And then there's other people who reach out because they're looking for very practical TM1py support. They have questions like, what if something breaks in production? Who can I call? And if you have these kind of thoughts, maybe you want to reach out to us. So let's look at what is included. We provide you access to a ticketing platform, the same platform that we use for Pulse and Arc. We guarantee response time. We guarantee to fix bugs and flaws. You do get priority on requests regarding the TM1py product roadmap. We support the utilities, the main ones, RushTI, NDXPy, and kubecalc. And we also want to include some time for review and mentoring. That should definitely help you to get started or give you more security if you want to make sure TM1py in production runs smoothly. Okay, the second offering that we bring into market is TM1py in the Kubewise cloud. So this is definitely tailored for TM1 cloud customer. So the situation is probably that you've got TM1 on the cloud. You want to use Python, maybe for data integration, maybe for something predictive, maybe just advanced analytics. Want to be able to write Python scripts, but at the same time, you prefer Python to run in the cloud as well instead of on-premise. So what you need in that case is a platform to develop your Python scripts, to run them, and also to schedule them. And so what we did is put together a very little image in the cloud. It hosts Jupyter Lab. It's kind of like Jupyter Notebooks 2.0. We put some custom extensions to it, like scheduler, which isn't included by default, and then it allows you to interact with it through the browser. So let me give you a quick demo. All right, so you should be seeing Jupyter Lab. By the way, I'm testing this through the browser, runs in the Cubewise cloud. Here you have a bit of something like a file explorer on the left, where you would have multiple files, you would have CSVs, Python scripts, Jupyter notebooks, and then your Jupyter notebooks, they just run, right? You could just create a Jupyter notebook and run this thing. And so let's go through this notebook, and it's a very simplistic Python script that looks at the inputted data in a cube, and it does some kind of like outlier detection. So we want to make sure that all the numbers that have been inputted are plausible. So that's the task for the script. Maybe let me show you the cube shortly. This is the cube, some inputted data here, some quantity, some sales data here that has been inputted. If you see that all the dimensions are prefixed with Northwind. If you're interested about this, next week we're doing a hands-on TM1py session where we look much deeper into the cube, and yeah, we will do that during the in-person events again. I definitely recommend to join that. So that's the cube. Now let's use TM1py to pull some data out of this cube into Jupyter, play with the data, calculate some stats, maybe plot something, and draw a conclusion. So let's first, it's going to prompt me for the password. Now with the password, we can connect to TM1 in the IBM cloud, like that. So we didn't raise an error, so we connected. And now what we can do is we can execute a view and pull the result of the data frame. So you see here in the function, we're providing a cube name and a view name, and we retrieve something that we call df. That's df thing, that's just a convention. It's a data frame, so we call it df. Let's take a look at this thing. Okay, so this is this is the same data that we saw earlier in Architect. Sales data by customer, city, country, etc. So now what we could do with it, first of all, of course, we could bring it into CSV. So you can call the toCSV function, and now this CSV file was created. So that's a quick win. But let's do some statistics here on this data set. So first, let's start with some descriptive statistics. You can call the describe function, which gives us a couple of descriptive statistic measures, like the quantiles. So we could see that most of the values fall between 8 and 80 here. The median is 37, and there's 100 values in that view, and the maximum value is 2008. And that already looks a bit suspicious, given the quantiles and the median value. 2008 looks a bit suspicious. So let's maybe visualize it in a histogram. So what we can see here is that there seems to be some kind of outlier. Like among the 100 values that have been inputted, it seems like one of them is way off the chart. Here at 2000, possibly someone wanted to write 200. So maybe as an analyst, maybe let's find this record, put a little comment on it, and send it back as a cell annotation or as a comment. So first thing we have to do is we have to find which record exactly is it. And that's just all this functionality built in nicely into these pandas data frames in Python. So if you wanted to know the max ID of the value column, so which record has the max value, it's ID 34. And how does this record look? It's this one. So that's an order for Munich in Germany, 2008. All right, and now to finish this off,
let's define a little comment here. Value is implausible. Please double check data entry. And then we send it back. So we're using a TM1py function here called write value. It takes the comment, the name of the cube, and then element tuple. And now if we refresh this, we should see the comment there. Oh no. I'll let this refresh for a second. Okay, let's try again. I'll let this refresh. I've got one more slide. There it is. So here's the comment that we wrote with TM1py. Value implausible next to the 2008. So I've got one more slide for this presentation, and then I'm happy to take questions. Happy to speak about Git as well, if someone's interested. Okay, so I think that sums it up quite neatly what we've been up to recently. And let's take a look at the vision of a TM1py, broken it down into short-term, mid-term, and long-term. And in the next 3 months, we want to release TM1py 2.0. The last one was 1.10. And for this release, we want to make a big architectural change. So don't worry, we'll make sure that everything is backwards compatible. But for the even though under the hood we have to make a few architectural changes to take full advantage of async requests in TM1. That's a functionality that TM1 has implemented now for a while. And TM1py doesn't really allow you to make use of it. And in a way, if TM1py made use of that, it would allow you to write different kind of more efficient Python scripts. So because now, if you're doing something in from TM1py, you sort of like you trigger a process, or you clear, or like you're reading some data, whatever you do, Python just waits in that line, and it just waits for TM1 to send the data back, respond. With the async requests, we could write code differently, much more efficiently. We could sort of like kick off an operation, and then Python just continues. And then eventually you could sort of like you could double check with TM1 has this operation completed. It is, of course, it is more complicated to use, but it's very powerful. And we want you to be able to do that. Currently, we don't even allow it. So that's something that's definitely coming, but it's not easy to implement. Then we want to do user-based login in the IBM cloud. Again, that's something that's missing. Currently with the IBM cloud, you would have to use the non-interactive account, and we'd want you to be able to do that with your own user, possibly with IBM Federation. May make it a bit easier for us to do that. And then something that's not entirely in our hand, but something that's very important to us is to make sure that we catch up at the raw of write speed. So when it comes to like 100,000 cells from a flat file into a cube, at this moment, Turbo Integrator is faster than the REST API, so it's faster than TM1py, and we would want a TM1py to catch up. We would like it to be on par, and of course that's not entirely in our hands, but we're working with IBM to address this, and I think that'll be a big moment for TM1py when we can say not just your scripts are faster, but measuring like raw throughput, we are just as fast as Turbo Integrator. In the six months, we're thinking to kick off this TM1py Community Council. It's not very healthy for an open source project if KubeVirt makes all the decisions, and it'll be more healthy if we could have some kind of group of veteran TM1py users and developers from the community who make decisions, prioritize developments, and also make these kind of architectural decisions that I just talked about. And then in the very long term, we would like, we're thinking to establish TM1py as the obvious choice for data integration for PAOC. Because as we think at this moment, if you're running PA in the cloud and you have a data source that's not ODBC or flat file, TM1py is the obvious choice. But we're trying to convince the community, the TM1 world, that TM1py is the right choice. And then the last point is is possibly a bit controversial. Like there's a bit of a personal vision that I have. I think TM1py could even be the default choice for scripting in general. I think it could substitute a Turbo Integrator to a degree. And I know this is very controversial, not Wirtz's opinion. But again, next week in Sydney and Melbourne, we're going to have like discussion panels. And this is a question that we definitely want to debate. When is the right choice to use TM1py and when not?